Our first short talk will be from our lab PI, Kurt Weber.
Okay, hi. I'm going to give a sort of an overview of what's happening with force a little bit, and then we'll drill down into details with the presentations that come after. And these are going to be very short updates to get everybody thinking and get everyone thinking about what they want to ask at the town hall part of the town hall meeting. So force, you can see on the author list here, you have the five PIs of force, also Kara Brugman and Kyusei Tsuno, who are research scientists, and then Stephen Wynn, who's a project manager of force. And they're all here, and they're all going to have things to say today, along with Carl Agee, who's our guest speaker. Next slide, please. Actually, I don't know if he knows he's our guest speaker, but hopefully he does. So a lot of you already know this, but a quick summary of what FORCE actually is. It is a mid-scale NSF project, and NSF always wants us to say that and remind people that's what this is. Directly funded by NSF so far, and it stands for the Facility for Open Research in a Compressed Environment at Arizona State University. And when people like Dan Shim and Pam Burnley came up with this acronym, the word open became very important to us. So we really want to keep having it in the name. Helps us remember that we are trying to make an open facility where people can come and do high pressure experiments, learn high pressure, or they already know high pressure. They can use equipment that they don't otherwise have access to. We directly report to David Lambert mainly, and also Doug Kowalewski. David Lambert is in the Instrumentation and Facilities Division of NSF Earth Sciences, not division. Yeah, it is a division, sorry. And we also report upward to the Geosciences Directorate on a quarterly basis. We just finished one of those reports a week or so ago in a Zoom meeting. Of the total budget of $13.7 million, $6.7 million was awarded in October 21. And based on a satisfactory first year report, the remaining funds were awarded in September of 2022. So now we have all the available funds to use for building the laboratory. And I should mention this is a project to build a laboratory. So next slide, please. Here's an org chart, and you can see people on this org chart, the PIs and everything, and how we report upward to NSF, and who our main reporting is to, which is the Geosciences Directorate Senior Management. And over on the left, you'll also see Alex Navratsky's name on the Center for Materials of the Universe, which is related to FORCE, and it's Alex's center here at ASU. And we're still trying to figure out exactly how to make the org chart so that MOTU and FORCE are both represented in their proper, it's possible that FORCE could be part of MOTU, for example. Next slide. And it's going to be a national facility that's going to provide capabilities, and we have four main large tools, and then we're going to talk about smaller capital items that Kyusei will be talking about. So the first large tool is the 6,000 ton press. We've ordered a press from Sumitomo, and it's well underway. We're expecting it fairly soon. Steve Wynn, the project manager, will talk about the schedule momentarily of when we're expecting these things, and he keeps tabs on the schedule even when it changes. So it's a very important thing to know what's coming. This press is, the main purpose of this is to have larger forces, and we're going to use larger carbide cubes. We'll have the ability to use 52 millimeter, 65 millimeter, or even 75 millimeter carbide cubes, which means you can put more force on it because the first stage is steel, and you can only put so much force on the steel carbide interface. But if the carbide cubes are larger, we can use more force. So basically, the cell assemblies, the multi-anvil assemblies and samples will be larger. You have to think about what you can do with a larger sample environment. You can either make larger samples for property measurements, or you can enhance the sample environment by putting pressure buffers and other things inside. So we want everyone to think about things that they would like to do with a press like this. Okay, next slide, or the next item is the high precision cubic press, Jasmine. And the purpose of this, it's specially designed to create a more cubic environment so that you can use more brittle anvils such as ultra hard carbide and sintered diamond, and go to higher pressures than the normal 25 GPa limit of the normal multi-anvils. And so this one is actually made by Vogenreiter in Germany, and it's designed after the one that Katsura has, which is called Iris. That's the one in the photo. Ours is going to be called Jasmine. Next slide, or next thing. A torsional stress apparatus called Twister for doing experiments in torsional stress for physics, and with proper heaters that we need to develop, we can also do earth science experiments under torsion, simulating the proper temperature inside the earth. And the last item is a 6.89 kilobar internally heated pressure vessel, which will have, it uses argon to create pressure on a large sample up to, we call it a low pressure device, but it creates quite nice samples under a very uniform temperature and uniform pressure, because it's using gas for the pressure, and we'll have the capability of adding hydrogen, a little bit of hydrogen, using a Shaw membrane so that we can have a controlled FO2. Apparently, argon is quite oxidizing under normal conditions out of the tank, but this will control the oxygen fugacity for earth science type experiments and others. Next slide. Here's the lab layout, just very quick. So there's where Ichiban will be in the middle, and Jasmine will be over there in the west side of the lab, and Twister is up there in the northeast, and then the gas vessel, which we haven't given a nickname to yet, it will be in the southeast corner. And then we have all these tables in the back for sample preparation. We have a glove box, and we have a small chemistry lab on the left side. And all the auxiliary small equipment that QSE is going to talk about will also be located in the lab. And we've chosen some of the equipment. We haven't made decisions on all of it. That's one of the things we can talk about today of the smaller equipment. Okay, next slide. This is us touring the lab. This is about half of the space. There's currently a wall behind where I took the photo, and the other half of the space is on the other side of a wall. That wall will be removed, and the place where Kara and Steve are standing in the foreground is actually where Ichiban is going to be placed. Okay, next slide. And then this is from our advisory committee visit. This is just the PIs and the outside advisory committee, who many of you will recognize some of the faces in here. We've got Gabriel Gomezia, Pam Burnley, Yanbin Wang, and Carl Agee. All right, so now we'll go into the talks. This is Kara, you can say who's next, I guess.
Next, we have a construction update from our project manager, Steve Wynn.
Morning, everybody. I'm going to give a quick overview of where we stand with construction and some of the things we've been working on. Next slide, QSE. And you can go through these next 4 pictures too, QSE. So as Kurt talked about, we've got 4 major pieces of equipment, all of which have been procured. We went through, for some of them, quite a lengthy, detailed selection process to make sure we got the right pieces of equipment. here's the proposed or current delivery schedule for each one of them. Each bond should show up this summer. Twister, the high pressure torsion device, is expected to show up sometime this spring. That might get pushed just a little bit. We're still waiting on a confirmation of their final delivery date. The gas vessel will arrive sometime later this year, probably around mid-December. The Jasmine won't show up until July of next year. It's quite a lengthy, almost 2-year manufacturing process for them to build that. It's fairly complicated. Next slide. So here's where all those pieces of equipment fit into our construction schedule. This is pretty much the layout that Kurt just showed, the proposed design of the lab. We're right now working on issuing the purchase order to Core, the company that will head up the construction, and their schedule is currently to start demolition next week. There's a lot of demo work that needs to be done to prepare the lab for this equipment, taking out some sections of the south wall so we can put up large roll-up doors, and removing a lot of the existing slab in the south side of the lab. Currently, I think the slab is only about 6 inches thick, and it'll need to be up to 36 inches thick to support the weight of some of these presses. Construction should start in early May, with the new slab being completed by July. Once the slab's completed, we can start moving the presses in. Twister, the HPT that will be up in the northeast corner, will go in first. That'll be in September, followed by the Ichiban, which is the largest press, with a lot of it's a pretty complex process to get something that large onto campus and into a building. So we'll be coming through I think right now the plan is the parking lot by the use building, and then come around the front of ISTB2 and in through the middle roll-up door. That installation should be complete by mid-November, with substantial completion of the lab by just before Christmas. That substantial completion is going to include installation of those first 2 presses, the sound enclosure room that has to go around the pressure vessel, a platform that will go around the Ichiban. We are not installing this in a pit as it is done in a lot of facilities. We're installing the unit on the floor, and the operating area of the press is about 7-8 feet off the floor. So we're building a steel platform around the middle where the loading part of the press is located, as well as building a dumb waiter. I think you can see that in the middle lower left, for lifting and retrieving samples up to the press. We're going to have a 10-ton bridge crane that will be installed, as well as finishing the upgrades to the HVAC, lighting, all the utilities. That should all be done by mid-December or towards the end of December. The plan is to protect the 2 presses that are in place or that will be installed at that time, so that we can start working with those presses outside of the rest of the work that's being done in the lab. The pressure vessel will be installed in its room in the end of January. Jasmine will be installed mid-August when it arrives from Germany. And owner occupancy, meaning the chem lab, the glove boxes, all of the workbenches, everything inside of the lab will be completed and turned over to us in early September of next year. Final completion, including restoring any of the landscaping on the outside, finishes to the outside of the building, that will be done shortly after that in October. So the current schedule is the entire lab will be finished by October 1st of 2024, which will give us about 2 years left on our grant to then prepare the facility for hosting researchers. Next slide, QC. In addition to the lab, which is on the first floor of ISTB2 in the southwest corner, we have an office space for the center that is directly above that lab space. And in its current configuration, it will support a 24-seat conference room, 4 offices for ASU staff and faculty, with office cubicle or offices for any visiting faculty, cubicle space or potentially office space for grad students, reception area, an informal meeting room just to have research discussions, and then 2 breakout rooms, which if you're familiar with ISTB2, there are 2 glass enclosed small meeting rooms on the mezzanine level that are being refurbished so that we can use those. We have plans for expansion of this office space over the next 3 to 4 years. As we get more users to the facility, as it gets commissioned and we have more people using it, we have the option of expanding our office spaces farther to the west or to the east, so we can include more, up to, we're planning on 8 offices for visiting faculty. We just had the design meeting for this space with the architect earlier this month, and we're estimating being able to move into our offices by the middle of July of this year. Next slide, QC. And that's all I had.
Thanks, Steve. Next, we're going to
bet.
talk about outreach activities from Tom Sharp.
We'll talk about broader impacts in general, but let's go ahead with the next slide. So we have an undergraduate intern program, interns and workers. And when we wrote the proposal, we defined 2 different types of undergraduate positions. Interns are students that have a research project with a reportable outcome. So in other words, they really have to be doing a science project. And those interns would then present their research results at the end of their experience. Student workers are a little more flexible. Student workers can do any task that's needed in the lab, but the way we're going now is we really think that all of our student employees should do research and present their results. A major part of the proposal was to bring in construction engineering interns to work with the design and construction companies. This has turned out to be more difficult than I had thought. But the idea was to train students in modern lab design and then provide an additional link between users of the lab and designers of the lab. My opinion is that the architects that design labs don't generally know enough about how we use them. Next slide. So we have one construction intern, Thomas Montanez, and he's in the construction management program at ASU, and he's working directly with a construction company. We have Isaac Roden, who is an undergraduate hourly worker now. He was one of our interns as well, and then a new intern, Aaron Mann. So the idea is to keep a steady flow of undergraduates working in the lab. So currently there is no lab for them to work on. They're working in there's no force lab. They're working in the multi-anvil lab and learning about multi-anvil, and we'll transition them to the force lab as it becomes operable. Next slide. So diversity, equity, inclusion is really important in the proposal and in this project. So our initial recruiting for interns has been through ASU departments, science and engineering departments, but we're now starting recruiting that targets specifically underrepresented STEM student groups, such as the Society for Hispanic Professional Engineers, the National Society for Black Engineers, and Women in Science and Engineering. And so it's really important to reach out to those groups to promote the internships if we want to have a diverse cohort. Our interns will be mentored by faculty and research scientists. And this is important because the mentors have to define the science goals and supervise the progress. right? And we don't want to have students come in and be sort of set on Kurt's lap to oversee. We really want quality mentoring from the whole group. And so Kara and I have been working on a mentoring agreement to provide clear expectations for mentors, mentees, and staff. We also need and want to provide a safe and inclusive work environment. So we're starting a code of conduct document, and we will be developing a lab safety document as well. So we really want to make sure that these issues are addressed. Next slide. So we have some other outreach activities. For example, Kara mentioned our new LinkedIn page, so check that out. We are presenting talks and posters at conferences. So for example, COMPRES last year in AGU, and we'd like to do more of those. So if anyone has opportunities for us to give talks and so on about force, we'd love to present and promote our project. We've been doing outreach at ASU. For example, we had the School of Earth and Space Exploration New Discoveries lecture series last year, where Dan and I presented work on high pressure and force. We have on-campus activities such as Open Door, which is next weekend, where Kara and others are developing sort of a hands-on outreach activities, and we'll be presenting those at various campus outreach events. We had our annual force workshop in January, and we've been working on an official logo and branding. So this cute little icon there is not what we will be using. We had a discussion with branding today, but we're working on some nice logo and branding activities with ASU. Next slide. So future plans, and this is important. We're going to have a summer undergraduate research experience in years 4 and 5, so 2025 and 2026. This will be an 8-week summer program. We're looking at housing opportunities and so on. So we haven't scheduled exactly what that time frame will be. We will have 10 students to come in to be trained in high pressure research techniques, and this is for undergraduates. Our ASU interns will help mentor the program, and we plan to recruit from minority serving institutions to have a very diverse group. We also have 2 PhD positions that are funded by the Force grant for 3 years. Those PhD positions will participate in testing, calibration, development of new assemblies, and really helping us get the new facilities up and running and tested. We will also have a summer school for high pressure research in the last 2 years, 25 and 26. This will be a 3-day school workshop for graduate students and postdocs, where we'll have expert lectures and sort of state-of-the-art activities and applications. And our summer undergraduates will also participate in that and present their research results as posters in that school. And finally, we will be coordinating with the Industrial Affiliates Program through the I-Ring Materials Center to offer excess synthesis capacity to industry partners. So we've had a long-standing program in the I-Ring Materials Center and the Center for Solid State Science, where industry folks have used excess capacity, and they've paid industry rates for it. And we intend to take advantage of that opportunity to help subsidize some of the costs.
Okay, next we'll hear from Alex Navratsky about our faculty developments.
Okay, so just one comment to add what was just said. ASU has just very recently been granted the status of a Hispanic serving institution. So that opens doors for other funding that one can apply for and makes it easier, of course, to attract students. The Arizona community itself is quite heavily Hispanic, both in the Phoenix area and also in outlying agricultural areas, for example, around Yuma. So we expect that that this will also interact with force. What I'd like to talk about is some of the other things going around with MOTU and force. So MOTU, the Center for Materials of the Universe, which is something that I helped organize as part of my coming to ASU a little over 3 years ago, really addresses 2 things. from the point of view of planets, we argue that planetary science and the understanding of planets is the biggest inverse problem in material science. A forward problem is one in which you say, here's a material, what are its properties. An inverse problem is, here is a planet many light years away. Here are a few observations of properties. What is the planet? How has it evolved? How will it evolve? What implications does it have for Earth? So in a sense, then, all of planetology is governed by the properties of materials. So MOTU tries to bring together people with backgrounds in planetary science with people with backgrounds in physics, chemistry, and material science. The second role of MOTU is essentially to think about new materials and how various materials can in fact be used in planetary science, space exploration, etc. So when I came to ASU, I was promised, and it was delayed a little bit with the COVID year where there was no hiring, that in addition to my own position, there would be 5 faculty positions related to MOTU. So the first position is Hongwoo Shu, who is a professor in School of Molecular Sciences. He's a thermodynamicist, crystallographer, solid state chemist, geochemist, and he came about 2 years ago. We then had a little bit of a hiatus because of COVID, but last year we basically hired Jeshu, no relative of Hongwoo, and she's essentially a biogeochemist specializing particularly in transition metal chemistry and transition metal bacterial interactions, which of course from the point of view of MOTU and planetary science has a lot to do both with the origin of life and of course with current interactions between the organic and inorganic world. We now have 2 faculty searches, which we are hoping to conclude within a few weeks. One of them is for a faculty member in MOTU broadly, and this is somebody that is essentially a solid state chemist working on materials problems of interest to the broad scope of MOTU. And the second is we've dedicated one of those 5 positions to high pressure, that is to force. And again, we have interviewed candidates that basically work on high pressure, will interact certainly with the force facilities, but will also interact with both School of Molecular Sciences and School of Earth and Space Exploration. I cannot say more about those at the moment because negotiations are underway, but we're very excited about our candidates, and we will hope to be able to announce good news in the not too distant future. Some other things we're doing, we're developing courses. I think Tom mentioned some of that. I've been teaching a seminar, graduate level seminar course, which was about centered about high pressure last year. This year it's centered about collaborations, and particularly we've had a number of our contacts at the national labs speak to the class. Of course, we are submitting a number of proposals. Obviously, the force proposal was our successful big proposal. We currently have several other big, mid-size, and small proposals in the pipeline. Hopefully, some of those will be funded. We realized that our next task over the next 2 years will be to seek permanent or funding for force as a national center rather than as a development grant. And we're going to start talking with NSF, DOE, DOD, NASA, etc., to really be able to bring force onto a more stable sort of thing. We also are making plans to hold a workshop, something analogous to what's been held in the past, and I think perhaps that'll be talked about a little bit later, because we see force as filling the gap between high pressure research that's done at synchrotrons and high pressure research that's not done at synchrotrons. And this is something that we're very interested in developing further. So those are the things that are going on in the broader picture. And thank you.
Thank you, Alex. Next, we have supplementary facilities from Dave Smith.
Hi, folks. I'm Dave Smith. Just to alert you to the fact that ASU has, as part of the core research facilities, we house the I-Ring Materials Center. And that center historically has had a wide range of current cutting-edge characterization facilities, far more here than you're interested in catching. I'm not going to go through all the items, but the most important thing for us is that when people come to use force, you'd like to have some idea of the success or otherwise of your experiments. And so we have the possibility to make use of the I-Ring Materials Center. Particularly, we can do some optical spectroscopy. We can, down the right-hand column, we can do some XRD of the powder, high resolution XRD. We can do some compositional analysis. And if necessary, we can also make arrangements to do electron microscopy. So going down the left-hand column. And so we do have facilities on campus that we can prepare FIB samples. We have extensive facilities where we can prepare crush samples and do the sample prep. And at the end of the day, we would hope that a combination of doing your experiments using the force equipment, characterization through the I-Ring Materials Center and back again, and maybe there's a repeating cycle, maybe 3 or 4 cycles before you succeed in getting the sort of materials that you are hoping for. So the facilities are there. It's a shared use of facility. We would have to make arrangements. We can't sort of walk across the campus, knock on the door and expect to get the FIB or the aberration corrected microscopes on demand, but we can certainly arrange that these facilities can be accessible to everybody who comes to use force. Okay, thank you.
All right, thank you, Dave. All right, does anyone have any questions about those topics before we move on to our discussion section? Okay, I don't see any hands. So let's move on to the first topic, directions we want to go in science force. That will be presented by Dan Shim.
Hello, everybody. Can you see me and hear me?
Yes.
Yes. So I want to talk, this 5-minute intends to be more of the for the initiation of the discussion rather than the conclusion. So the force will have, next slide, 4 different presses, which can cover a wide range of pressure temperature ranges and wide range of the physical conditions and chemical conditions. And we want to utilize this new capability for doing exciting science. Next slide, please. So there are actually guiding documents that are given to us. In fact, FORCE was funded through one of these white papers written by the community. Next slide. If you click once, yes, that's one. So Earth in Time was the community sort of consensus collection of ideas, what would be the important science to do in geo and earth science in next decades. And in this document, there was a highlight of the importance of acquiring large volume press that ultimately, lead NSF to decide to fund this project. There are many exciting topics out there, but one of the emphasis in the document is to understand the early Earth. And certainly, all the Earth can be characterized by many and largely very different physical and chemical conditions. Our hope is that, few of these presses allow us to tackle this problem. Next slide. And we also have a new opportunity to expand to the exoplanet science. And if you look at recent community documents and recent news articles and recent research highlights, there are consistent trend that you can read in these documents that to be able to understand the spectroscopic measurements, mass radius experiments that are going on in exciting space telescope missions and ground-based telescope missions, it is essential to understand thermodynamics, chemical reactions, etc. For the combination of materials that are not necessarily relevant to the Earth, but relevant to the diverse sort of planetary settings we see out there in our galaxy. Next slide. And we also have an interesting opportunity in terms of coordinating the effort between FORCE and other user facilities like NIF, APSU, which will be upgraded in a couple of years, and LCLS2, which will provide us with the new capability. You can think of providing high quality, dense materials from FORCE, but you can also think about developing window materials for allowing gas and liquid to be studied in these facilities. There are many other ways to harness this new capabilities together. Next slide. So here, these are just examples. I think it's more for the initiation, and we also love to hear about new ideas as well. There were some ideas of FORCE doing some sort of sample shop type of role where we synthesize high quality single crystalline, polycrystalline materials to support diamond anvil cell studies, for example, or shockwave studies. And then we have a collection of them, like a shop that we can provide through the mail delivery and etc. The second idea is to have consistent effort of covering wide range of mantle minerals and hydrous minerals and different type of minerals that plays an important role and consistently and continuously measure the physical property under FORCE initiative and accumulate those data for seismologists, for example, or geochemists or exoplanet scientists. And certainly some of our presses will open up a new area of deep mantle petrology and geochemistry, and chemical applications such as super hard materials would be very exciting. And also the FORCE might play an important role of technical development and then transfer to industry and individual high pressure lab. That's it.
Okay, everyone, what do you think? You go back one, Kyusei.
Okay, so I talk about the supporting equipment, which is very helpful for high pressure devices. And this is the first slide. I will talk about the supporting equipment good for preparation before starting the high pressure experiment. I listed several, and the first two 1100 degrees C to the 1700 degrees C macro furnace and 1 atmosphere gas mixing furnace. This can be used when you want to synthesize sort of the geologic material or other type of material synthesis using the reagent oxide powders. And after synthesize the starting mix, and we can keep the starting mix in a drying oven to avoid the mixture. And if you want to pack the starting mix in a metallic capsule, and currently we are thinking about having the Lampert's pack welder shown in a photo on the upper right. This is nowadays in a high pressure science field. This is very distributed. And the advantage of this one is by using the metallic electrode, like a tungsten or, for example, tungsten electrode, actually the very low temperature welding would be achieved. And if you want to place the fluid in a capsule, and it is not likely to be devolatilized, and it retains in the capsule after the welding. So this is the advantage. And next, I will talk about the computer numerical control milling machine. So this can be used if we want to machine very small cell assembly for the multianvii experiments, which is suitable for tungsten carbide cubes, cell assemblies, which can be suitable for tungsten carbide cubes with like 2 millimeter or 1.5 millimeter truncated edges. So using this machine, we can fabricate very precise assembly parts. And of course, we can also use a benchtop lab to fabricate the cell assembly as well. And for cutting the assembly parts, and we can have the isometric precision cutter with the diamond blade. And finally, in this slide, last one is the stereo microscope. This is very important for assembling the very small cell parts. I go to the next slide. Here, I'll talk about the good supporting equipment after the experiment during the sample preparation. We can have a semi-auto grinder for polishing the samples mounted in epoxy. And diamond abrasive with lubricants or aluminum slurry with water on velvet cloths can be used for the good polishing in general. And for example, the EPMA and FTIR analysis in particular. And next is a Princeton scientific high precision wire saw. Picture is shown on the right, and we can place very small sub-micron experimental run charge on a spot shown in red. Then we stretch tungsten wire with 20 to 50 micron in diameter, shown in a dotted line in orange. Then when the machine's working, tungsten wire move back and forth while dropping the glycerol with silicon carbide powder from the top, which facilitates the cutting. We can also have petrographic microscope with camera to see the texture after polishing the samples and to collect the image of the surface. And we can also have vacuum chamber or vacuum oven with vacuum pan. If the recovered run product is very fragile, then we can impregnate the surface of a sample with epoxy or super glue in a vacuum chamber. And this is my last slide. This one is one of our capital items, which include the equipment for the elastic velocity measurement. This is I talked about supporting equipment before the experiment and after the experiment. This is during the experiment. For this measurement, we will have a lithium niobium oxide transducer. You can see the picture on the left. And we can have the pulse generator, waveform generator that's in the middle. and oscilloscope picture on the right. So the basic theory is we can generate the ultrasonic waves from the transducer on a truncated edge of tungsten carbide cube, and send the ultrasonic waves in the cell assembly under high pressure and high temperature during the experiment, and it detects the signal coming back from the cell assembly using the oscilloscope. So these are the current supporting equipment for the high pressure experiments we are thinking about, and later it's good to get the feedback from you guys. Thank you.
Yeah, thank you, Kisei. Okay, Kisei, let's go back to your slides before we move on. Let's talk about the sections that you and Dan spoke about. Does anyone have any comments about the science that we should focus on first, or the auxiliary equipment to support it? I noticed that in the chat, someone asks, will high pressure work be able to be done with radioactive and or F block materials? I think that's a question for you, Kurt.
I don't actually know the answer to that question. It has to be done through our safety office. We have had people ask about that before in our existing lab. Does anybody have any experience with that?
Yeah, feel free to unmute yourself and jump in if you have a comment.
Yeah, just in terms of dealing with ASU safety related to radioactive materials, you have to go through certain steps, but what matters the most is the amount and the radiation level, amount of sample and the radiation level. So some are easier than the other, but I think this is certainly an area that we need to discuss actually in the future. Depends on how much of a demand out there it is for this type of experiment.
I might add that we've been dealing with uranium and thorium materials ever since we came here, and there's really not a big problem as long as you do all the paperwork right and you keep on good terms. You know, if you show them goodwill, they show you goodwill.
And I think, adding Alex's comment that with respect to the uranium and thorium, from the geochemistry side of the view, some people perform the behavior of uranium and thorium during the early Earth differentiation stage, like in the partitioning of these materials between the metal and silicate, or maybe some other stuff. Then I guess some of the other labs already conducted experiments, something like that. Probably that they experienced the sort of the safety issue or something. So maybe we can get the idea from people if there is like a geochemistry, like a scientist, and we can get the feedback from them.
Okay. And we also have a question about auxiliary equipment. Are there plans for an atmospheric control like a glove box for oxygen, air, water sensitive samples so they can be prepared with minimal exposure? And in short, yes, that is part of the lab plan, if we're able to go back to that slide. Does anyone have any suggestions for other equipment maybe that we've overlooked in that list that Kisei presented?
I just had a comment. This is Carl Agee. So COMPRES and I think maybe Jesse Cars also have purchased these micro manipulator setups, and you know, it's to be used with a stereo microscope, and so I'm just wondering if that's an item that would be useful in sample prep or autopsy work on quench samples.
So in fact, we had that item under consideration when we wrote a proposal and get funded. At the same time, we are aware that the institutions like BGI own this type of instruments, and we talk to the graduate students and postdocs there to learn about how useful it is. This is fairly expensive equipment. So it ranges between 150 to 300K. So investment needs to be made carefully. We often find that some micromanipulators may have a function more suitable for diamond cell than multi-anvil scale, but we can also think about sort of other options, because in biology there are a lot of different type of micromanipulators at different price range for the different scale of the sample. So I think it's a good suggestion. We just have to find the one that is designed and more suitable for multi-anvil scale.
And also, I also agree that micro manipulator is a very good equipment. For dealing with the recovered products. And also I guess during the preparation of the maybe cell assembly, maybe micro manipulator may work if we want to make the very small ceramic assembly in the cell parts, especially when using maybe the 6.55 1.5. 1.5 means tungsten carbide cube is truncated edge length. This type of when dealing with a very small assembly, and it could be that micromanipulator may also work for the fabricating the assembly parts. I'm not sure, but yeah. Yeah, just I mentioned here.
QC, could you please go back to the lab floor plan slide during Steve's slides so we can show the glove box location?
One moment.
There we go.
That works.
This
So
one works,
the glove
right? Yeah.
box is in the top right corner there with the hands. We also have a question. This person wonders, are there cutting facilities that can work with hard materials? And I'm not sure how hard this person means.
I believe I'm not sure either which kind of like a hard materials, but when using the isomet with the diamond saw, and diamond saw means so the stainless plate, but the diamond is dispersed on a margin of the blade. So we can definitely cut the very strong hard material. And also when using the Princeton scientific wire saw, I go back.
I should add that we have excellent machine shop facilities, and actually they're one building over from where Force will be.
Yeah, we've had them do diamond grinding on some of our samples. And then for cutting diamond itself, people usually use a laser, right? A high frequency laser. I don't know where to have that done.
And also, I'm not sure which type of material, but if the recovered product after performing the experiment is like a very hard material, then we can use Princeton scientific wire saw, and we place a tungsten wire, and we drop the glycerol with the silicon carbide powder. So yeah, with respect to the recovered product, we can cut very hard material as well.
Okay, and Sarah Stewart put a comment in the chat that she is interested in the idea of Force hosting a materials properties database. She says, I have compiled currently available materials, properties, resources here. She gives a link, impacts.wiki/materials. And she asks that we please send any additions that she may have missed. And Dan says that a database would be great, that we mean to take more systematic measurements of materials.
That sounds like a good topic for the next proposal as to what FORCE will be doing.
It does. Dan notes there are quite a number of minerals, for example, without elasticity while measured.
Yeah, for example, I learned that there are quite a number of hydrous minerals stable at shallow subducting slab conditions without really well characterized elasticity. So covering those minerals more systematically for longer term, and build the consistent database that seismologists can come in and then use those data to understand their images and measurements would be one area that FORCE as a sort of community supported institution can take a lead.
There's another connection to a big national initiative on critical materials, and critical materials are basically, or critical element is anything that if the supply is interrupted or doesn't exist, the technology really suffers. There's a lot of interest in rare earths, but also in cobalt and nickel, particularly with respect to battery applications. There is a big DOE project, which may get bigger. There are things we're involved in, and some of that includes synthesis of critical materials or investigation under high pressure. So I think that's a sort of it's a geo area in the sense that finally all materials come from the earth.
Okay, do we have any more science ideas or equipment ideas before we move on to our last guided topic?
So did we adjust the earlier question about allocating?
I'm going to bring that one up during the open discussion since it's slightly off topic. And then we also have a comment in the chat that bulk modulus and shear modulus are not well constrained for a lot of hydrous minerals, even less if we were talking about single crystal elasticity. Yeah, so it sounds like there's a lot of interest in that topic, so we'll be sure to include that. All right, let us go to our special guest speaker, Carl Agee, to discuss the possibility of a meeting this year.
Hi, can everyone hear me? Yeah.
Yep.
Is it possible for me to share my screen, or it's not critical, but.
Sure.
Okay. Oh, just a second. Okay. Can you see that? It's just,
yes, we can.
It's just a slide showing some past in-person and compressed annual meetings. And the reason why I like to show slides like this when talking about these open user facilities, especially, for example, the ones that COMPRES has supported for the past 20 years, is that, at the end of the day, it's all about the users. It's about people coming into these facilities and being able to carry out their experiments, be successful, get good data, and leave, with a very satisfied feeling that they've accomplished something. And so this is a critical part of any of these facilities. And so the question, I think there are a couple of things here that I wanted just to touch on, and then we can open it up for discussion. First of all, just let me make a comment about FORCE. I wholeheartedly support the idea of having an early, maybe it's an annual meeting, but in any case, a kickoff meeting for FORCE, an in-person meeting. And the idea there, of course, is to get lots of input from the community, but also to educate the community about the new facility, about all of the things that are potentially possible, to have people coming in talking about why they're excited to use the forest facility, how it will advance their research. And then, the thing that we always noticed with COMPRES, the thing that I was totally amazed about, I guess I shouldn't have been completely amazed, but it was one of the really satisfying things about running the COMPRES meetings was that there were so many students and postdocs who were involved. And in fact, we had, I think, the participants at the COMPRES annual meetings were at least half students and postdocs, if not more. And so we're looking at the next generation, the people who, again, who are going to be using these facilities over the next 20 years. And this is a critical part of training, of education and outreach, but in a very sort of direct way with our community. And so I'm very, very supportive, and I'm encouraging force to, have such a meeting. I don't think that they, we're not planning to have one, but I think it's an excellent idea. And then on a related issue is the, what happens to what's going on now with NSF supported high pressure research. And of course, this is force is a fantastic testimony to NSF's belief and support of this field. So that's just a real feather in the cap of the high pressure mineral physics community. But we're also facing a time of change and transition. As many of you know, COMPRES is being sunsetted. In fact, should have been sunsetted back in May of 2022, but here we are in a so-called bridge funding interval where we're essentially waiting on the NSF awarding a new cooperative agreement to manage the synchrotron facilities that are essentially make up Jessicars and COMPRES. And so where high pressure fits into this new organization, obviously it's going to be there, but on the other hand, COMPRES, which is coming to an end, was completely devoted and focused on high pressure research and on mineral physics. And so that very strong emphasis, and especially the outreach that took place within COMPRES over the years, the question is, how is that going to be maintained, and who's going to step up, and how is that going to work? My main concern is that some of this may get watered down. I don't think that's probably the right word, but there's a lot of things probably that are going to be going on in the new organization that is going to be replacing COMPRES and Jessicars, or I guess the so-called COMPRES Jessicars merger, which is now something beyond that, actually. So where do we want to, I guess, just put it out there? How do we maintain the focus on this community that we've created over the past couple of decades? And so I think force has a role to play. Obviously, the new organization, once that award is made by NSF, it will have a role to play. As I said, COMPRES is coming to an end. It will be, right now as I said, we're in a transition period. So I suspect that COMPRES will probably be coming to an end over the summer, or maybe as late as the fall of 2023. So that's really all I had to say. I mean, I think this is a perfect topic for the town hall. I just gave you a few of my ideas, but really it's, we need to hear what people think. Should we have COMPRES style annual meetings? Personally, I think you just cannot do without in-person meetings. We suffered tremendously from the pandemic. putting us all on Zoom, which is, very helpful if you're just, need to quickly get in contact with people, but there's nothing that can match an in-person meeting. So I think I'll stop right there and I'll unshare my slides. Let's see if I can stop doing that. And we can open it up to well, I'll just hand it back to you, Kara. So.
Yeah, we've been talking about possibly having a meeting in the fall. And we first spoke about this a bit at the winter workshop during the open discussion section then. But what do the people here think? Is the compressed style meeting something that you would like to see continue? The impression that I got from people who have been often in the past was yes. Sarah Stewart says yes! Exclamation point. Yes, we have a bunch more yeses in the chat. And Kelsey says, I think meeting is a great idea. Potentially the first meeting could be after Ichiban is installed in November. And Ben replies that he thinks that's a great idea. We were considering having the meeting in Arizona, and maybe not necessarily in the Phoenix area, maybe get out of town a little bit, see some scenery. But depending on how things are going with construction and what the safety issues might be there, we could take a peek.
Just my perspective on this, I think it's great to have a retreat style. You saw the mountains in the background. That was actually in not too far away from where I live, so it wasn't that remote. But yeah, it's great to have a retreat style where people can come together like that and be, really develop lines of communication on a very personal level. I think also you have to, once you get the ASU facility ready for prime time, you want to have an on-campus meeting as well. And for me, I'm really also interested in all of those support facilities that are at ASU and learning more about those and how you get access to them, because that's a bit of a mystery to me. But I think that's the sort of thing that would be great to have in terms of a on-campus meeting at some point. So both of those, but I think it's critical there are a couple things that are critical. I think it's really important for FORCE to use an annual meeting style venue to develop its community, just like COMPRES developed its community over 20 years. And but then also there is this other thing that's going on with the so-called COMPRES Jesse-Cars merger, and where is high pressure mineral physics and high pressure research going to be? Where is that focus going to be in terms of meetings and so on? So how is that going to fit into all of this?
Yeah, and one of the really interesting things about COMPRES is it sort of combines several communities, the online and the offline high pressure communities, as well as some others. And also COMPRES gave out subcontracts, so there were a lot of people that would come because of that as well, because it created a kind of a connected community of researchers.
One of our advisory members says, Pam Burnley says, I think we need to do some soul searching as a community as to what are the boundaries of the quote community. The COMPRES community may not overlap completely within the FORCE community. It is important to realize that where community boundaries get drawn impacts the underlying science.
Yeah.
I think another goal of FORCE is to involve the non-geo, non-planetary, high-pressure community, and that means chemistry, physics, material science. That's something that tends to be fragmented, by the stovepiping at NSF. So we need to also see how we can bring those other communities in, because both to increase usage, but equally importantly, to increase scientific communications and develop, in some cases, more sophisticated measurements.
Yeah, Pam agrees, and Sarah says, kind of along the same lines, I hope the various high pressure communities can form a new umbrella organization of some sort. This would be all the different fields of application and static and shock. And she notes that the shock community is small and shrinking and somewhat dispersed. So they would like some more interaction with the static community. This might be a good time to tease that we are also starting a seminar series. We're having a couple of seminars starting this spring, and then we'll have a full schedule in the fall. And our first speaker actually is someone who does shock. I actually have a question for everyone. Would people prefer that this kind of meeting be more of more like a mini conference type of event, sort of how COMPRES has been in the past, where a lot of students give talks, or is there interest in kind of a workshop component also? I could see a lot of value in people coming to learn about the other applications of high pressure to the types of science that they're not directly familiar with.
You can actually have your cake and eat it too. So So what we did typically with COMPRES is we would have the annual meeting, and then we would have, like, the day before the meeting, we would have 2 workshops, let's say, that would be in the facility. So you would have like breakouts. It's sort of like a pre-meeting workshops. That also is a really economical, efficient way of doing it. There's nothing, of course, I mean, obviously workshops can, you can have workshops on all types of top subjects, and they don't have to be with the annual meeting, but it worked really well for us when we did that. And in fact, one of the, I remember the 2015 COMPRES annual meeting that was held in Colorado Springs, the workshop that was the day before was actually had to do with the large volume press. So, and that was very well attended. And again, that was sort of the early stages of what now is FORCE.
So in the chat, Emmanuel Sognard, who is our boss at Eyring Material Center, he says at least the first few years, having a workshop component included would be important to include newcomers to the community. And Kelsey agrees. She says, I think the workshop would be helpful. And then once people start using the lab, seeing the work that is coming out of those visits would be awesome. And I think personally, I'm most interested in a workshop or maybe like a tutorial component before talk sessions, just to help get everybody on the same page. Because sometimes, especially in fields that are as, I don't know, there's a lot of equations, there are a lot of different kind of subdisciplines within high pressure. And it's really easy to have a talk where people kind of blow past getting people on the same page to understand what's happening. And I think that's extra important with anything we do because we're bringing together so many subdisciplines. And someone also mentions in the chat, in terms of different communities that we would be bringing together, what about scientists from other countries? As far as I know, there wouldn't be any constraint about who could come.
Yeah, like COMPRES, I think we are open to anyone from wherever.
Yeah, I mean, personally, that's the thing that, Tom, that I really liked about the COMPRES meetings. And in fact, that's how I ended up getting involved in COMPRES, is because I thought the annual meetings were so good, And I'm not talking about the ones that I ran, but the ones that were previous with Bob Lieberman, let's say, or Jay Bass. You go there and yeah, you would hear, the updates on the facilities and so on, but they would have keynote speakers from, neighboring disciplines. You would have all these student talks. It was just a lot of really, really excellent new science that was being presented, and absolutely not a closed shop, right? A very open, welcoming environment for people, for anybody who's curious about this stuff. And again, I don't want to, beat this, don't keep talking about this over and over again, but the fact that we had such a strong student and postdoc component in these meetings, I thought was just absolutely excellent.
Well, there were some
And-
other really great things about it too, and that
Yeah.
is you would generally put them in beautiful locations. They're relatively short duration, so you don't get burnt out. In a 2-day meeting, you don't end up getting burnt out. You get excited, whereas a whole week at AGU can be a little tiring. So it was a really great meeting from that respect too, right? And really good keynote speakers, as you mentioned.
Okay, I do want to continue this discussion, but a couple of other topics have been brought up in the chat. So let's go to those before we circle back to this if we have time. In terms of auxiliary equipment, Bin Chen notes, it may be a good idea to have a laser cutting machine to cut metals or ceramics. A UV laser cutting system would be ideal. Our group built a UV laser drilling cutting system, and it can not only cut gaskets for diamond anvil cell, I believe it can be used to cut electrodes, rhenium furnaces, etc., for multi-anvil cell assemblies.
That's a good thing to add to our consideration list, I think. That for cutting things like rhenium furnaces, we have our furnaces in the project we have now are cut outside at a company, but that doesn't really work well for prototyping. It only works if you're cutting something standard that you can cut many identical pieces of. So if you had your own laser cutter, that would be nice.
And also in the COMPRES assembly, like alumina disc is also prepared using the laser cutter.
Cut what? Sorry, I didn't.
Oh, sorry. So in the COMPRES cell assembly, rhenium heater, that's metal, and also the alumina disc is also prepared, or alumina ring is prepared.
No, those are mostly made by extrusion or. Yeah, I think the only thing we cut with the laser is the rhenium heater right now. But I'm sure there are other uses for it, for a laser cutter.
Here's something you might want to say more about, Kurt. For our standard multi-anvil lab, most of the materials, most of the assembly parts are produced or mass produced through the techniques you've developed. I'm assuming you're planning to do the same thing for larger scale. Is that the case?
Yeah, as long as it's scalable. Yeah. I think we're thinking a lot about using the same techniques. There's a limit. We injection mold the octahedra, and when they get bigger and bigger, sometimes you reach a size limit for injection molding because they're made with wax, and the wax has to be removed from the part. But I'm planning to try to continue using the same methods, but we'll also look at other possibilities, like what they do at AHIME, for example.
Okay.
Emmanuel says laser cutting would be great, assuming we can afford it. Emmanuel, you can find us some extra money, right?
It may not be particularly expensive. I don't know. The laser welder we have was about 40K, which is I would call that expensive, but we may be able to get something for less.
I think there's a lot to gain from having a way to cut with a laser. Bin Chen says, yeah, it's fantastic.
Let's see. Yeah, Bin Chen was talking about it.
He says we built our own
40K,
system.
so
it costs 40K.
It's just what I said, 40K, but I guess that's pretty much standard for laser stuff.
Yep.
I'll volunteer to help build our own.
Yeah.
Okay, in the chat, we also had a question about user time. The question is, I was wondering how you allocate force time between ASU and external users. Will it be a proposal allocation system like APS? I think in short, yes, probably. I think at the beginning, if depending on what user demand is, we might be delayed in setting up a proposal system, but that I think is the ultimate plan.
Yeah, we're thinking, that's what we're thinking about doing, is having something like what they do at APS, and we'll be having some meetings to talk about that soon. And also early users may wind up being people who are interested in helping or working on calibration and that kind of and testing, since that's what we're going to be doing at the beginning. And then science experiments will follow.
But I think it's very important that we do set up such a system. We haven't worked out any of the details yet, but we're happy to take input from the community as well, in terms of their ideas, your ideas about how a large user facility could be set up and whether or not the same type of systems APS is appropriate.
It's also true where anytime someone has this wonderful cutting edge breakthrough experiment, of course, we would try to make it happen. The more visibility that high pressure research has in the general external materials research community, I think the better for everybody all around.
In the chat, Kelsey Preisel asks, she says, this is such an exciting effort. I have a question about user visits once the lab is up and running. What duration are you expecting for visits? Weeks, months?
Yes. I
All
think
of
the
the
visits
above.
will vary in length. Yeah. And some people, I know when I was a grad student, I went to Japan for 2 months to Eiji Ito's lab, and that's where I learned high pressure research, multi-anvil research. So some visits would be very short. Somebody might want to make one sample, and you just want to make sure you have enough time to succeed, and others might be projects that take longer.
We do
That's
have
one reason
space.
we have those offices as well, I think.
Yeah, we've got
Exactly.
space to
Yes.
accommodate visitors, but the problem is you don't want to be coming here in the months of late February through March when every local accommodation goes through the roof in terms of cost. The rest of the year, we can probably provide reasonable cost accommodation nearby.
In terms of the first users being involved in developing and calibrating the system, Emmanuel says, I was fortunate to be one of the students testing Kurt's new assemblies when they were developed, calibrated. It was an amazing experience, and it also allowed me to do great research. So no one should not be worried about being involved on the testing side.
And I guess the other thing I'd say about users coming, I think that we will probably make inquiries about the possibility of graduate students at least being able to be accommodated in some of the local ASU dorms. It's more difficult for us to do that with sort of faculty level people, but I think graduate students, we've had graduate students in the past who have been accommodated in the dorms. And if they're not completely overflowing, then that's certainly a reasonable way that people can come for an extended visit without having to break the bank, rob the bank to pay for it.
Yeah, we've had summer visitors do that from various places and spend a month or so in a dorm. Of course, they have to come here in the summer, but
yeah, I know in when I was a graduate student in the School for Earth and Space Exploration, we often had emails out to the grad student listserv just to see if someone had a spare room for a couple of weeks, that kind of thing. And we were able to accommodate a lot of postdocs and visiting students that way.
Which certainly we would not like to have people just coming for a short period of time and then have an unsuccessful result at the end. The important thing is that when people come for shorter or longer periods of time, that they go away with lots of results rather than leaving empty-handed.
Yes, agree. I know some of the beamlines, like the beamline in Hamburg, they have contingency days, I think. So if something, the beamline goes down, you don't get your data during your scheduled time at the end of the, forget if it's the end of the week or month or something, there are a couple of days to pick up whoever might have not gotten their time. So you could think about adding something like that in too.
Yeah, I understand that Kurt is volunteering his weekends if we need extra people to work.
thanks, Dave.
Yep. No, but we want to have a very welcoming facility, and the more people that go away happy and with impressive results that serve their scientific needs, then the better off everybody is.
Oh, and in case we didn't answer your question explicitly, we do have in our office plan specific visitor offices, so faculty level offices, and extra desks planned for grad students, so that they will have a place to have their sort of office home when they visit. So all of the area also to the right there that's shaded in are areas where we could possibly expand into if we're getting enough users to put in more visiting office space.
I might mention that we're also negotiating right now to get these graduate areas enclosed in a room rather than being out the way they're shown on the drawing.
Yes. We have a question about the user proposals. How will the proposed studies be evaluated in the future? I don't think we've gotten that far into the specifics of exactly what the criteria will be for the evaluation, but what we have talked about is, like APS, a similar style where there'll be an outside review committee.
Yeah.
I think it's very important.
Yeah, at APS, they, as a lot of people know, they have the proposal review panel, which is generally people from outside APS and some people from inside, some people from outside, that meets 3 times a year. And after the proposal review panel gives the proposal a recommendation or rating from 1 to 5, 1 being the best, then there's a beamline allocation committee that decides whether the beam time exists and whether the experiment is feasible.
And it is our goal to be as equitable with the time in the lab as possible. We have a comment from Rick Hervig, who's on our internal ASU advisory committee. He says, besides the wonderful equipment in the Eyring Materials Center for sample characterization, our secondary ion mass spectrometers, the IMS-6F and the NanoSims, are NSF-funded national community facilities that would welcome working with users at the FORCE facility. We have been concentrating on HCN and lithium, beryllium, and boron and isotope ratios for some years. And then we have another question. What is the status of the existing multi-anvil facilities at ASU while the FORCE lab is getting up and running? They're running. Big Blue's running almost constantly.
The existing lab is in its own room in a different building, not too far away from FORCE, but it's not being moved, although it was moved a year and a half ago. But it's going to stay put now while the FORCE lab is running.
But there are room for
say.
visitors there too, if people want to come and do experiments.
I mean, the existing lab, the existing high pressure facility is part of FORCE. I mean, FORCE exists now, it's not waiting for the building.
Yeah.
So if people do want to come and do experiments, it's certainly possible to do it now.
Yes, the existing multi-anvils are still in use. Alex might have some students doing experiments right now, actually. Okay, any other general questions about the lab? Or maybe about the meeting? Emmanuel states, for the existing multi-lab, all you need to do is submit an iLab request to get access and to be trained. And probably check with us to make sure that we can actually do your experiment. I mean, we can do it, but give us a heads up that you're interested.
I don't know if it's time to go back to talking about the meeting yet, but
sure.
Can I say something about the meeting?
Yeah.
So I think the community involvement in planning the meeting would be great. So if anyone here is interested, or if anyone's interested in helping or thinking about that meeting, you can contact us. And there is something in NSF called a proposal. It's a meeting proposal, and it's described in the proposal guide. It's about a 3-page description. And so you can actually ask for NSF money to help give the meeting, since we don't specifically have this in a line item for this in the FORCE budget.
And I think
that's what I wanted to say.
Applying to NSF for the meeting, part of which will be to plan what we really want FORCE to be after the implementation. We sort of view this as a first step in writing big proposals to continue the funding of FORCE in whatever manner it'll happen. So again, we need, we need everybody's participation and help, just as we had when we wrote the whole big proposal that got FORCE funded. I think, the proposal that Kurt put in, a tremendous selling point was community participation, and that has to continue.
Yeah, I mean, with COMPRES, we always had a program committee for our annual meetings. So even though the central office would, run all of the hotel issues and, all of on the travel, et cetera, there was usually a chair and then a couple of other people and maybe a student, a postdoc representative who would essentially, work with the central office to put together the program. And I think that for FORCE, one of the things that's really going to be really important to do well is to have community participation from the outside. I think someone mentioned it earlier. COMPRES had one advantage in that it had multiple subawards. So there were people who were getting money essentially to be part of COMPRES for good reason, right? To pay for beamline scientists. But that's a really concrete form of outside interaction. Something that's very tangible. So FORCE doesn't have subawards, and therefore the outreach part has a bit more of a challenge to it in that regard. But I think it'd be really good to have this program committee work with you guys on the meeting. So it's not just an ASU thing, right? It's from a bunch of different participants, nationwide and international. So,
is there anybody in the town hall right now who would be interested in volunteering for this committee? Sarah volunteers, also Kelsey. Great, thank you. I will be in touch. Sarah also says, this is a good idea. I was wondering if a little polling to identify key needs would be helpful for the community. I'm thinking of which topics are key for student training for workshops. Could be more general than training for a specific piece of equipment. Or given ASU's online course experience, could we have some online training tools as part of the workshop? And she says we in the community would help develop these training tools. I think a poll is a great idea. I can put something together, like a quick Google poll to send out to our mailing list. And if you say you want to flash our social media contact slide, if you're not already on the Force All mailing list, you can sign up at force.asu.edu/newsletter, or just, newsletter. Okay, does anyone have any other questions before we conclude?
One question might be, how does the community feel about the timing of the next town hall? Should we do it in 3 months or 6 months? Maybe in 6 months' time, we'll have a very good idea how we're going with as far as the renovations are concerned. We'll be well along at that stage. And yep, okay.
Yep, Pam says 6 months sounds better.
And in 6 months, we can have a better idea of how we plan to to handle applications and users. Because I think we need to bring some more details to the table to talk about.
Okay, thank you, everyone. We will see you in 6 months. We'll see you also on Twitter, on LinkedIn, on Instagram. Please do sign up for that mailing list if you haven't already.
Thank you, everyone.
Thank you.
Thanks.
Goodbye.